I don't know. I think we need to ask because Mark knows how to do that.
So if you'll notice, my video set up to whoever's got their microphone on is who gets the big picture in the middle. So I keep seeing you scroll by.
I was going to say, for those that don't want, that are whispering in the background, all they have to do is hit Control-A, and it'll mute you, and then you won't have to whisper.
Or if you've got dogs barking in the back or a kid that runs by, there is, down in your toolbar, there's a mute. And then there was a keyboard shortcut, Control-A. Is that what you said, Rick?
Yep, that's the one.
Or just mute. Okay.
Or Alt-A, I'm sorry.
Alt-A, okay. So, and usually when I'm watching, if I'm not being the teacher, I usually do mute just in case, the phone rings or the office is loud, and that just gives it a quieter spot for everybody else. Okay, I know we'll be missing some of our advanced master gardeners because they are headed to, there was a class at the Idaho Botanical Garden tonight, so they were headed to that. So I got to see everyone. I was at Jim County last night. We had our Living on the Land class, and I know she'd mentioned a few times that they were meeting Monday night for gardening club, and those two things didn't touch base until we were in the middle of class, and here comes all the garden club, and I'm like, oh, I should have put two and two together. So they had to meet in the little tiny back room, and we kept things going in the main room. But like two different worlds, you don't schedule both at the same time. Okay, and I'm going to hold on, never mind my email. I'm just checking to see if anyone is stuck and not able to get on for. Looks like we might be missing Mia still. Okay, so because I do have a full hour of presentation, I'm going to go ahead and get started, and then hopefully people can join in if they need to. I might have to stop and answer an email or a text if we've got people that are still stuck not getting on, but all of you made it, so that's great. Okay, so let me work on this share screen thing again. Okay, so tonight's discussion is going to be on soil physical properties. So we're going to discuss everything that's not chemical or biological. So next week we'll talk about nutrients and bacteria in the soil and different parts of organic matter and compost that you can add for soil health. This one's going to be all about the physical properties, so the drainage and the texture and all those things that are just kind of innate to the soil. So in the slide here, you can see we actually use letters to designate the different layers of soil. I was lucky in college. I worked for the soils lab, and they came by and they're like, hey, guess what? We have a national soil judging competition. And they're like, and we really need another person. And I'm like, okay, I'll go ahead and do that. And I got to go all over the nation judging soil, which seems like a really weird thing. But they dig a big pit, and we'd have to distinguish where the different layers were and all the physical characteristics of those layers. And so I got to see sand in Arizona and glacial till in Wisconsin and red clay that was full of water in Georgia, and it was kind of a fun experience. So it makes me kind of appreciate the soil we have here. We tend to not have an O layer at all, so that's like a humus or organic matter layer. If you think like the forest where there's a little stack of leaves, our soil just seems to be on the top there. Okay. Let me
Oh, so she knows when you mute.
Yeah, and if I can hear somebody, so there is a mute button there. If that way you can feel free to chat with the other people in the room if you need that.
Why don't you mute it?
Okay. So it's kind of hard to know what is under your feet, you know, and unless someone goes and takes a backhoe and digs a big hole in your backyard, it's hard to distinguish what you have.
There.
So these are 3 examples of soils that we would typically find in our area. So that first kind of tan one is right here in the Treasure Valley. And so it's an aridisol, a very arid soil. That's why it has the lighter colors. If you show our soil to anyone that lives on the West Coast, they're like, what's wrong with your soil? It's all light colored and looks horrible. And that just happens to be the soil you get in an arid climate. So it's not as much organic matter and a little lighter colored. So if we go to the middle one, some of us are blessed with a ton of rock or gravel in our soil. Some of this is from volcanic activity and water moving rocks around. We just get all those little clumps of basalt that end up in our soils. And then sometimes some really shallow soils, so we don't have a lot of depth to bedrock. As we go down closer to southern Idaho, they'll have natural hard pans or caliche layers in their soil. So that's kind of the white layer above the bedrock. And that's soil that's lost almost all of its organic matter and nutrients out of it. It tends to be super hard and not the best for growing things. So figuring out what is under your feet, other than digging a big hole, we have a couple resources for that. One of the reasons that all this soil has different characteristics is there's organisms in our soil. I talked about the bacteria and the fungi and the nutrients. Time, some soils are older than other soils. So soils that are usually next to a river or at the bottom of the hill, they're going to be kind of younger soils. They're kind of always in changing. Topography, so the soils on the top of a hill versus the bottom of a hill are going to look really different. Climate probably makes the biggest factor. As I said, that one really light soil is because it was in an arid climate. So dry climates change what the soil looks like. And speaking of like going to Georgia, if you're in a wet climate, you're going to basically rust the soil. So that's why it's such a bright red color, is all the iron in that soil has turned to rust. And you get, high clay and the rust. And then a little bit has to do with the parent material. So was it originally basalt or was it sandstone? What got eroded to create that soil? And soil forms super, super slow. So the given factor is 1 inch takes over 1,000 years. But that's actually in a better climate than we have. So that's in a climate where they actually have warm and wet summers. With our dry summers and our cold winters, we actually form soil a little bit slower than that in Idaho. So if you lose 1 inch of topsoil due to an erosion event or due to a wind blowing away, it's going to take a long time to form that soil again. Okay, so to be able to tell what's under your feet, the Natural Resource Conservation Service has a site called Web Soil Survey, and I'm actually going to click this link and go out and show you how to use it. This is best. The soil characteristics can change dramatically over a landscape, so this is more of a large-scale tool. So if you're on a itty-bitty quarter-acre lot, the soils underneath that, it's not quite to that resolution. But if you have 5 acres, this is going to be a pretty good tool to show what you have. Other things that affect it, kind of have the Landozer picture out there, like home construction and grading, severe erosion or water movement, a bunch of fill dirt additions. That's going to change what the native soil looks like. So in those conditions, your soil survey might not match what is actually underneath your house. But in most cases, especially in rural Idaho, it's pretty darn close. Let me see if I can make this work for us here. So this is the Web Soil Survey. Someone speak up if they can't see it, but I'm hoping it's on your screen. You okay?
Mm-hmm.
Okay, great. So we're going to say start the WSS right there. And I was playing with this earlier, so it's telling me that I need to start a new session. And This can be, it's a government website. It can be a little bit clunky, so hopefully it wants to play today. There we go. So this starts out with a map, and almost all of the U.S. has had soil surveys done on it, especially all of the agricultural areas. So there'll be some areas, you know, the top of Mount Bora doesn't have much soil. They never bothered to go up there. You're not going to have soil survey. But basically any place that houses are built or there's land are going to have maps in here. So we're going to just start by like state and county to get ourselves close enough so we can see a chunk of land. So we'll go ahead and go to Jim County just to go with the majority here. So Jim County's in the middle of the map, but we're still pretty big to do anything. So I'm going to zoom in here on Emmett a few times. So we get close enough that we can see a field or an acreage too. Okay. If you really want to zoom in, if you make yourself like a little square, then it'll go just to that square. So that'll help you go in a little faster so you're not clicking over and over and over again. Okay, so now we can see some fields, and we want to say what area soils we're interested in. So I'm going to click this square box that's defined by rectangle. If you've got an odd-shaped property, they have defined by polygon, and you're just picking out the corners of your property when you do that. And I'm just going to pick this big field right here as just an example. And it's a click and hold and drag instead of clicking each corner. So we're going to make this plot our area of interest. And it takes a few seconds for it to determine what that is. I think since I'm zooming, it's taking a little more of the internet. And I also have 2 children waiting for their 4-H meeting on the iPads out in the office space. So that might be slowing down our internet a bit too. I just heard them say, I'm not on the internet, Mom. So at least they're not holding me back. Okay. So here we've got, and it kind of outlines in blue. It also gives you an acre figure kind of over here, so that can be nice to, you know, if I actually got the corners on the corners, and when zoomed in, if you need to know the acreage of a field, this would at least give you a good start on that. So now we're going to want to go over to the next tab, which is our soil map. So the soils are mapped in really large regions. So we're going to see a couple over this square that we've chosen. So on that left-hand side, they've actually named all the soils, and they will have weird names like Bissell and Harpt and Purdom. So a lot of them are based on local town names or county names or area names. But the main thing we're looking for is it gives us, okay, so we're getting a kind of an error here. The soil map may not be valid at this scale even. So, you know, we're on a bigger property, but it's still showing us the information we need. So that means like within this orange circle here that PUB, which is power and Purdom soils, is the main soil type there. And this area in the middle would be PUA, power and Purdom. So we're looking here, this one's a clay loam and a loam, power and Purdom soil. So that one, and not until you go in, loam isn't in the name, but I'm guessing they're probably similar. And then it says, out of the 58.1 acres, how many acres are this soil type, and the percentage out of that whole square you made, what percentage of that soil type it is. So let's click on one of these. I'm actually going to click on the power and Purdom soils. And it's going to give us a full description of that soil. So some of it is just a basic area information. So your elevation between 2,000 and 5,000 feet, annual precipitation is 8 to 12 inches, mean annual air temperature, frost-free period 100 to 170 days, and its classification, prime farmland if irrigated. Otherwise, it's sagebrush and cheatgrass. So description of power setting, the landform is on a terrace, which makes sense. We kind of saw a river coming through that area, and this was kind of a step up from there. And it is mixed alluvium and or loess. So alluvium is moved by water, and less is moved by wind. So that's kind of what we would expect for that being next to a river. And once again, those are all those technical words that take you semesters of soils to know what they mean off the cuff. So here's the part that most homeowners are actually interested in. Our A horizon, which this is what we consider topsoil, is A, is 0 to 9 inches and is a silt loam. So you don't have a ton of topsoil here. 9 inches is going to be good for most garden crops, but sometimes you'd like to see a little more than that. Then we go into a B zone, which is 9 to 27 inches, and it's a silty clay loam. So silty clay loam is going to be a little bit heavier soil. This would be a field that I might not want to go through with a deep ripping plow and pull up all that really clay soil and have it mix in with my silt loam. So that would be good to know. And then 27 to 60 inches, it goes back to a silt loam. And you see that a lot when you're next to a river, is as that river has meandered and moved, it's kind of changed the soil textures as it's gone. The great thing about this soil is there are no really thick clay layers, there's no caliche layer, and there's no bedrock. You've got a nice 60-inch soil. And that's as far as they test for soil survey. So 60 inches is as deep as they look. So you can see here depth to restricted features is more than 80 inches. It's a well-drained soil, which is kind of based on its texture. We'll look at some of that in a little bit. Capacity, the most limiting layer to transmit water, is moderately high. So available, that silty clay loam doesn't transfer water very well. So it's got a moderately high limiting layer. Depth of water table is more than 80 inches. No flooding, no ponding. Calcium carbonate, that's what makes our soils alkaline or not acidic. And it's also what causes those white layers in the soil. So up to 30%. It's not a salty soil, and available water storage in profile is high. So this is about 10.8 inches of water can be held in that 60 inches of soil, and that's actually a pretty good amount. As we go down here, you can see more and a few different descriptions of what this might look like, because this was a combination of power and pertum soil. So I think they're giving you power first, and then this is pertum down here. But this is some of the things that you can find on the soil survey. You can print this once you've got it all lined out. And I'm going to click over on the next thing, the Soil Data Explorer. Suitabilities and limitations for use. If you're wanting to put a septic tank in, if you're wanting to put a foundation in, some of these will give you what you need to know about those things. So let me pick one. How about waste management? See if it has any. And we want slow rate treatment of wastewater, land application. Okay, maybe that's not the one. I was looking for the septic tank one, but it must be in a separate category. But if we click on one of these, so if we were wanting disposal of wastewater by irrigation, this would explain all those is and what the ratings are, and it would show you the ratings. So that's just some additional information that takes a little bit to mine all that out of there, but that you can find about your soils. So I encourage you to get on here and kind of look and see what your soil is, or at least the native soil underneath your property, even if it's been constructed or land planed or something done with it. And that gives you a start on the physical properties of your soil. We will be doing soil tests. I'll provide information before we get together next time and bring the bags to put the soil test in. And that will give you, of the physical properties, only texture. But it'll give you all the chemical and biological properties that we'll talk about next week. Okay. Okay, so that's everything about soil survey. So now let's talk about some of these different soil properties that we're going to be concerned about. Let's start with soil texture. So this is kind of the main thing that's going to affect your ability to grow a lawn or plant a tree or grow a garden, is what texture your soil is. And no matter what you do, I don't care how many loads of sand you bring in, you're really not going to change your texture. There's just so much soil. If you think of a foot of soil 5 feet deep, just the weight and the capacity of that you're kind of fighting a losing battle to attempt to change your texture. So this is more of, let's find what it is and how we're going to live with it. So soil texture is based on the size of the soil particles. So you can see here, these are to scale but not to scale. So you can see that the gravel particle is about 1/16 of an inch, which is way bigger on your screen, but still to scale, you can catch on there. But they did that so that they can show you the difference between sand, silt, and clay. So sand's a little smaller particle in that 1/8 of an inch. And then silt is that little dot on the screen. And then clay would be invisible at this size. So these different sizes of particles is what makes up your texture. So sand tends to be a very loose material. It drains water very well. It's very light. Clay tends to be a very heavy material, doesn't drain water, it sticks together very close. And then there's this super confusing triangle, but once you learn how to use it, it's not too bad, but it always gets people on the first try. And it's your percentage of sand along the bottom. So if we start there, if we're on the clear left and we have 100% sand, then they're calling your soil sand. That makes sense, right? And if you go clear to the right and you have 0% sand, then you probably have a silt. And let's see, along the left-hand side is your clay percentages. So that goes from 0 to 100. You'll notice anything over about 40% clay, they just call clay. So if you've got a lot of clay in your texture, it's going to just act and react as full clay. And I know there's some places in Emmett that is the case, is that you have just a clay soil. And then whatever left over is your silt runs around that right-hand side. So it's kind of a triangular point. So if you ever use GPS, that's kind of the common. So let's say my favorite texture, because it's the nicest to grow in without any limitations, is a silt loam. So a silt loam, you're going to have about 20% clay and between like 40 and 20% sand. And then you're going to run in the 80% silt. So if we triangulate there, we've got, now that should add up, shouldn't it? What am I missing on this? So there's 20 and 30. I think they have their silt numbers in the wrong place. That's going to be my guess. Because that doesn't add up to 100. And I used to teach math, and I'm pretty sure that's how that's supposed to work. So, so if we go 20, 30, so that means something is wrong on this. Okay, so I will... we'll do more explaining that in person where I can actually point and this all works out a little bit better. 30, 20. I'm going to look at one more time just to see if I'm missing something. Yeah, I think I might have grabbed a bad picture on Google because that doesn't work. So you understand the concept. We will work on the numbers later on that one. So here's kind of a better explanation up close. So this is actually under an electron microscope. If you can see, the units here are 20 micrometers. And so the big S is on a sand particle. And then the smaller ones are your silt and clay particles. And then if we draw a drawing of this, you can see the pores. So there's macropores and micropores in your soil. So the large sand grains give you macropores, and that's kind of, gravity reacts with water best on the macropores. So a sandy soil is mostly the water is going to run down. And then the little particles are your kind of a capillary action. So the stuff that makes your water like move up in a straw just because they're close together. So if you've got a sandy, or a clay or a silt soil, then it's more going to be capillary action. Your water's going to move outward more instead of just down. So that's kind of the differences, how those pore spaces. And we'll talk a little bit more about how water and air react with these different soil textures. Yeah, go ahead and grab paper and pencil, Ryan. Do you need me to hand? Just a second, getting my kids sent off to 4-H here. That's okay. Here, you can have my pen. Here you go. Here's some paper. You're set. Have fun. While scheduling my webinar, I forgot about my own children's 4-H meeting. So luckily we got a good friend that'll pick them up in between. They are out there on the file folder if you need them.
Okay.
They're blue.
I know.
Do you see any? Okay, Jen will have some at the meeting. Children. Okay, here we go. So that's pore space. So one thing when we think about our soil is we tend to think that it's solid underneath there. I mean, that's just kind of our perception. But the mineral and organic matter only counts for about 50% of the volume of that soil. The other 25% or the other 50% altogether is air and water, and we're trying to keep that in a balance. We don't want a completely saturated, spongy, soaked soil, and we don't want a bone dry soil. So we're going to try to manage that air and water. But only 45% of it is mineral, and organic matter, if we get 5% in our area, we're doing amazing. Our like native soils have like 1.5%, 2%. So you have to really try to get to 5% with our soils. The soil actually has, we just talked about texture, and that's the fine grains of soil, but it also has a structure. So this is the structure of when you pick up a big clod of soil, what it's going to look like. So there's different structures. So there's columnar, and there's platy structure, and there's a granular structure. And actually just kind of loosely digging in your soil and then picking up a clod and seeing how that clod holds together is your soil structure. Now, a lot of our soils that have been tilled over and over again completely lose this level of structure. And that can be really hard on the soil. The thing that is holding those clods together is the organic matter and the fungi, and actually the bacteria make like a glue that glue your soil together. So if you're going in there and tilling maybe multiple times each year, you tend to lose the structure, and then you lose some of your ability for water to drain and nutrients to move. So this is the main thing that people that are talking about no-till, what they're going after is preserving this soil structure. And it's the overall, our larger structure. And we're going to talk at the end about some ways a gardener could go no-till and some of the advantages and disadvantages of doing that. So water movement in soil. So you really can't talk about soils without talking about the water and air balance in irrigation. And of course, in our climate, the irrigation is a pretty important part. So on that left-hand side, we have a sandy soil. And this is a demonstration like if you just took a hose out and sat it on top of the soil and let it run in the same place. So a sandy soil, in 15 minutes, that water would be down 12 inches. And then it would take about an hour to go 4 feet. And if you left that hose on for a whole day, it's going to go out of the bottom of the soil profile like 72 inches deep. But it wouldn't go very wide. You're going to go straight down, but very quickly. And we talked about how those bigger particles have those really big pores, so gravity is the main factor that makes it move down like that. So if we look at the right-hand side one, the clayey soil, that's the small pore space with your silts and your clays, and we're doing more of the capillary action. So the water is moving outwards versus just down. So it can take you 4 hours of watering to reach 2 feet, and a whole day to get down to 3 feet, and then 2 full days to get to that 72 inches. So where this gets to be an issue is like watering a tree. If you want to deeply water a tree, you're going to have to leave that hose on a lot longer in a clay soil than you do in a sandy soil to get it to move down. And if you're one of those people, I think it's the default setting on a landscape timer or a sprinkler timer is like 7 minutes. If you're watering 7 minutes a day in a clay soil, you're never getting past the first 2 inches. You know, it just isn't going to sink down. Now you might have to do that and turn it on 7 minutes like 5 times in a row, because the water just doesn't move down very quick. So it may all puddle up on top of the soil just because it has such slow capillary action down. But in general, most plants like to be watered deeply and then dry out a little bit and then be watered again. So that's pretty easy to do in a sandy soil, except you have to do it every day. And in a clay soil, especially a heavy clay soil, you could water once a week, even in the middle of the summer, if you watered for a long amount of time and actually got the water down into the profile. And we'll talk about irrigation systems a little bit more later on. So this is the water holding capacity of the soil, and this can be kind of a hard concept to get or to understand. So on this right-hand graph, there's a bottom line that says permanent wilting point. So this is like after you go past this, the plant is not going to like unwilt and come back alive. So it's a really nice way to say your plant is dead. So permanent wilting point is you've dried it out so much and you've wilted it so much that you've killed it. So then the opposite of that is field capacity. And that's how much water you can actually put into that soil before it starts to pond up. So I like to think about field capacity if you take like a kitchen sponge and you put it in the water and then you pick it up and the water from gravity kind of drains out, but the water that's left in that sponge, that's kind of field capacity. So we talked about the soil water, you know, we're balancing with air. You notice the percentage on that left-hand side only goes to 40%. So, you know, you've got some of that that's air. So even at full field capacity, we're still only 35% water. We're not ever reaching 100% water because we have half minerals in there, and we need to leave a little bit of room for air. So one of the challenges is with watering is if we look at sand, that's the very bottom of this chart, the permanent wilting point is like at 4%, and the field capacity is at 8%. So you just don't have a lot of water holding capacity there. And if we look at the table, you know, we have less of 1 inch of water can be held in that whole foot of soil. So sand just doesn't have much capacity to hold water. And that's why we have to water it quite frequently. So if we move over somewhere in the middle here, let's look at the silt loam. So the permanent wilting point on that is about 12 or 15%. And the reason that goes up is because in those smaller soil textures, the plant like has a big straw, and plants can only suck up that straw, that stem, so hard. And because all those particles are tight together, it takes more suction to get water out of a finer texture than it does the thicker texture. So that permanent wilting point kind of goes up as you go up in your clay texture. But then your field capacity goes up too. So, you know, maybe it's like at 15% for a silt loam, but you can go clear up to 35% for field capacity. So you have this nice 20% range to play with. And if we look at the table, that's, you know, 2.5 inches per foot. So double and almost again of what sand can hold in a silt loam soil. So that water holding capacity really affects how you irrigate, and it really affects the hardiness of your plants. So if you're growing in sand, you're going to need some drought-tolerant plants just because you're playing with this little 5% range, and you're going to screw that up every now and then. You know, you're going to go on vacation or forget to water, and everything's going to die. Where if you're on the silt loam, clay loam side, it gives you a lot bigger window to work with. So you can water in the spring once every 2 weeks, and in the summer once a week. And, you know, really play with that range of field capacity. It makes that soil a lot easier to deal with. And as I said, whatever soil you have, you're kind of stuck with, unless you're going to move up into raised beds or grow in pots, which gets to be pretty expensive if you do a large area. And we'll talk about some ways to remedy some of the soil structure issues, but you're kind of stuck with your texture and the natural water holding capacity. So soil drainage. A good test for soil drainage is to dig yourself a 1 foot hole and fill it up with water. And this guy actually has taped his tape measure out there to make sure he has a 1 foot hole. And then time how long it takes the water to drain out of that hole. Now, a trick with this is if you like dig or push down on the bottom and compact the soil in the bottom, you're going to have really slow drainage. So you want that bottom of that shovel hole to be kind of native soil. You don't want to have compacted it or scraped it and, you know, made it compacted in any way. But this is a really good way to test your soil drainage and see how it does. I know I have a nice silt loam at my house, and if I filled a foot hole of water, I'd say in 10, 15 minutes it would be empty. It'd go pretty quick. Now, if you have a clay soil and you fill that full, you may be in the 3 to 4 hour range before that leaves. So it really does affect how fast soil water drains out of your profile. And some of the issues with soil that doesn't want to drain is it leaves your plant roots wet for a longer time and can lead to some root rot funguses and some declining health for your plants. Because basically, plants need to breathe. Plants don't breathe oxygen, but the organisms around them do. So in the soil, all those organisms, if you keep your soil really waterlogged and none of those organisms get any oxygen, then they're going to die and you're going to get anaerobic or no oxygen organisms. And that's, if you keep your soil wet too long, it'll actually smell like rot and sewage. And that's because you've switched over to those organisms that are more that way. We don't want to do that. There's some plants like bog plants or pond plants that are perfectly happy with no oxygen. They will live in that environment. Anything that's even the slight bit drought tolerant won't put up with this. So if you have some native plants that you're trying to get because they are low care, if you overwater them, they will rot away in a pretty quick fashion. So. So a separate thing we have to think of is infiltration rate. So this is how fast water goes into the soil profile from the surface. So the graph on the left, we can see that a constant application rate with the sprinkler system is kind of that line above. And if you reach a certain point, the soil infiltration rate goes way down, and that's when your surface ponding starts to occur. So this graph would be more similar to like a clay soil, that you put so much water on that the infiltration rate goes way down. You'll get ponding or erosion, water running off of the surface. On the right-hand side, I had to look at this one a couple times to figure out. So sand actually has a higher infiltration rate. It's higher up on the graph. So that's good. That means you can, and basically on sand, you can stick a hose out there and it doesn't even form a puddle. It just goes straight down. Where if you have a silty clay and you put a hose out there, it's going to run off or make a big mud puddle. It's not going to go down as quickly. So this really affects your irrigation methods. So that's where, a drip irrigation or a light sprinkler is a little better on those heavy soils than sticking a hose out there, because it's just hard to get that water to go down into the soil. So now we're going to talk about some problems that happen with our soil and some of the ways we can try to remedy them. So compaction. Soil actually compacts really, really easily. So the guy who's taught this before for me says that he has a squirrel feeder out in his yard. And the only thing that runs across that yard is that little, less than a pound squirrel back and forth. And he says the grass won't grow on the trail where the squirrel runs because the squirrel, with his little bit of weight, has compacted that soil. So it doesn't take much to cause compaction. And this is why I'm a fan of, if you're not doing raised beds, at least do designated pathways. Because, we tend to be just a little bit heavier than a squirrel, and moving back and forth in our garden can be enough to really compact the garden soil. So I just like it better if you've got a path and you stick to the path and you never ever step on your garden soil, just because we can cause a lot of compaction ourselves. I see this a lot in lawns. It's very popular to have very large lawn tractors now, and those are heavy pieces of machinery, and sometimes your soil's wet when you're going across there too. So you can get some pretty severe compaction even just from your lawnmower and lawn tractor going over your lawn. And this reduces your rate of infiltration, so the water can't get into your lawn. So it's kind of a weird situation, because the plants will look dry, your grass will look dry and horrible, but water ponds on the top of it and you can't get the water to go in. So that's usually a good sign that you've got compaction. And once you get compaction, then you get thatch really bad. So if you've got a layer of dead grass that doesn't seem like it wants to break down, usually that's because of a compacted soil and nothing to do with like the health of your grass. You can look in the pictures, the non-compacted, the water kind of likes to stick around the soil particles and you have all these nice air spaces and water drains through. When you compact the soil, you've gotten rid of those air spaces. And it makes it hard for plants to grow there. Okay, Suzanne's got a question. That's a good way to do it. Speak up or wave your hand.
So this is Shelley, and my question is, if you have compacted soil in your garden or your grass or wherever, can you do something to unpack it, rototill? What's the best way to get it undone?
So in a lawn, so probably taking what is that thing called? Makes the little plugs that come out of your lawn. That's about your best option without having to replant the lawn. So go through.
Is that aerating?
Aerating, thank you. Whatever that word is for aerating your lawn would really, really help with compaction. If you're in the garden, tillage actually does help. We talked about no-till and the soil structure, but once you're compacted, about your only way to get out of compaction is to till again.
Okay.
Prevent compaction is organic matter. So organic matter is like the secret to all soil challenges. So that's your compost, your peat moss, leaf mold, whatever you can find that's organic that can live in your soil. Other than sawdust causes some issues with binding up your nitrogen, but organic matter. And it's a little hard to apply large amounts of organic matter to your lawn. You tend to suffocate out the grass. So about your only way is if you do aerate and you sweep up all the little plugs and then go back and spread thinly compost. The compost falls down in those holes and you can get some organic matter back into your lawn that way.
Okay, awesome. Thank you.
You're welcome. So here's some pictures of kind of what compaction looks like. On the left-hand side, we have a good soil. It's got a nice granular structure in the topsoil, a little bit more of a columnar or clod structure underneath. So most of your root stays on the top, but some of your roots can go down. The plant's happy. On the right-hand side, we have a surface crust, and we'll talk about what causes crusting in the soils and what you can do to fix that. You have tightly packed crumbs in the top. Then you have large blocks of soil with few cracks in them. And the next problem done is subsoil compaction. So they'll call this, in a farm field, they'll call this a plow layer. So it's actually the bottom curve of where you plow actually like granulizes the soil. It makes it really soft and loses all of its structure. And that can actually be a line in the soil where no roots go past and no water will go past. So, they're plowing to get rid of the compaction, but at the bottom of that plow layer, you can actually get some soil issues there as well. So there's all the different problems that compacted soil can cause. So it's just not at the surface. It kind of can affect all the way down. And really your best thing for this, so other than that plow layer, would be to continue to till this. And we'll talk about some things you could do to get out of that the cycle of having to cultivate and plow to fix compaction. And not stepping on your garden beds is probably your best bet for homeowners. So soil crusting, and I have issues with this at my house. It probably has a little bit to do with just trying to plant in the spring and sometimes my irrigation practices. So this is a thin layer of soil that's really hard and crusty. And you can actually pick it up like a cracker. So I don't know if you guys have the same soil type, but I have issues with this. It can keep seeds from germinating. It's a hard enough layer that they'll get stuck underneath those clods. And this can actually be caused by the raindrops. So in Western Washington, if any of you have ever visited, they get this nice light rain that's, gentle and it happens all day, but it's not a deluge. And we tend to get some really hard rain. And the rain actually compacts the very surface of that soil. So hard rains is one of the factors that causes the soil crusting. The other one is irrigation. When we irrigate, those fine silt particles and clay particles kind of raise to the top, and they can cause this crust. So about the only thing that works for soil crusting is to have some type of organic matter on that soil surface that's going to break the speed of those raindrops and help that soil texture. So if you're working on a bare field, adding organic matter to the top, anything from straw to old hay to peat moss to bark chips will keep this crust from happening. And you may just need to do that to get your seeds up and out of the ground. I mean, it's a good practice to have that organic matter there anyway, especially if you're dealing with really fine seeds. I tend to have a lot of trouble with carrots because carrots take 14 days to germinate, for one thing, which is forever. I like 7 days. Tomatoes are great. But they also need to be watered most of the time. They need that moisture, and they're little tiny seeds. You can't bury them very deep. And I have trouble with trying to keep them wet. I tend to crust the soil over with my irrigation practices, and then they still don't come up. So this year I'm going to try, a thin layer of organic matter, probably straw. Living on the dairy where we have access to that pretty easily, that's an easy mix. I don't know if I would do peat moss because peat moss, once it gets dry, doesn't want to re-wet very well either. So really fine wood chips or compost or straw is what I'm going to try for my carrots to see if I can get them out of the ground this year. That tends to be my nemesis. So moisture level, and I think this time of year is the hardest thing, is you don't want to work your soil when it's super, super dry, and you don't want to work it when it's super, super wet. You're going to cause huge issues with your soil structure. So in super, super dry, you're actually going to destroy all that natural structure and get this fine dust of things. So if you've ever drove around in the farm fields in the beginning of the spring when things are kind of dry before irrigation comes on and we have these big dust storms and people are in wrecks because they can't see, that's soil that the farmers have worked a little too dry, and they've lost that soil texture, and they've got that really fine stuff on top, and it just picks up and blows away. On the other hand, your really wet stuff, first of all, you're probably going to hurt your back because it's going to stick to the shovel, and you're not going to be able to pull it up or move it around. It's kind of a pain to deal with anyway. But you're also smashing and compacting that soil and causing clods that just later in the spring you have to try to go back out there and break up. And if you've got a clay soil, that's going to be a lot of work. So my advice is to wait long enough in the spring so that it's dried out enough so it's a good texture to work. And then let's say you just left a bed fallow through the summer and it's becoming fall and now you want to do something with it. Water it the day ahead, get some moisture back into that soil before you decide to go and work it. So here's a method. So if you wanted to do no-till gardening, it's a process to work up to no-till. So first of all, you got to not have a compaction issue, and you have to have organic matter in your soil. Well, that's a couple-year process of building up that organic matter and only lightly tilling or just tilling enough to plant your plants in. So this is your instant no-till garden, and it's a method that someone else created, but they call it lasagna gardening. And they have a very particular layer of things that they want you to put in there. Nature is not this particular, so if you have a few of these things lined up. I've actually seen this done over the top of sod. So they'll usually put on that bottom layer, wet newspaper or cardboard would be your bottom layer, and that's to kind of keep that grass from just popping through all these lighter layers. And this one has straw, then horse manure. I'm not sure what lucerne hay is. I'm guessing that's a type of grass hay. They have pelletized manure, which would be something from like goats or bunnies. Fruit and vegetable waste. Chook manure, no idea what that is either. Bark chips, blood and bone meal, not actually blood and bones. You can compost dead animals, but I don't suggest doing it in your vegetable garden bed. Weeds and grass clippings, and compost or peat on top. So you just make this big bed, and usually you build this in the fall to plant to in the spring, so we're kind of off season for this idea. But if you were willing to wait a whole summer with that area just kind of being fallow, you could plant to it in the fall. You need about that 6 months to let this kind of mellow out and degrade. But this is an easy way, so there's no tilling. You're not tilling up the sod underneath. You're just waiting for this big pile of stuff. And this pile will be 2 feet tall when you start out. And by the time you plant in it 6 months later, it'll be about 6 inches tall. It'll just be a little bit fluffy. But I've seen great things from lasagna beds. And if you're patient and willing to wait that 6 months to be able to plant something, it's way easier than trying to cut out and roll out sod and get soil ready underneath. So I think a good way to get to that no-till gardening in a little quicker fashion. The other way to work with no-till is to do some cover cropping. So cover cropping's become more popular in large farms, but it's also very useful in the garden. So they've actually created this radish, and I'm not sure if it tastes good. I know cows will eat it, but I'm not sure if it's a human edible radish or not. Its whole point is to grow a great, big, huge, deep radish. And this is actually tilling the soil or preventing compaction by just having these gigantic radishes in the soil. And generally what they do, if they're using it just to reduce compaction, is they'll grow them all spring into summer. They'll chop off the greens in late fall, and then let those radishes rot over winter in the soil. And then that next spring, till it up. So you've added all that organic matter from that radish root into the soil without having to till and no compaction. So this is getting to be a more popular thing in large ag, but they do sell a tillage radish that you could use in small ag or in your backyard garden. Another thing that works good is they call it a green manure. So you're going to grow annual grasses or forbs. I just had something fall on my desk. Never mind that. And so you're going to grow this up. Usually you won't let them flower or go to seed, and then you'll till them back into the soil. So if you pick a legume that fixes nitrogen, like a pea, and you let the pea grow up, and then you till that back into the soil, you're doing a little bit of tillage, but you're adding all that organic matter back into your soil. And that can get you quicker to that no-till arena, just to have a really healthy soil. And we'll talk next week about what nutrients that puts in and the help it does with the biological, but this is kind of more the physical, that tillage radish and the act of putting those plants down in the soil really do a number for water infiltration and drainage and water storage and fixing some texture issues. Okay, so that is the end of my presentation. So I'll open it up if you guys have any questions. We're at 6:20, so I'm here for another 10 minutes. I'm going to go ahead and stop the share so I can see everybody's faces. Okay, anybody have a question? Everybody's really quiet. That's let me blast you with an hour of information, and then don't leave you much room for the questions. Okay, well, good. So next week, we're going to go over the chemical and biological properties of soil, and that'll include a little bit on compost. So my goal is by the time we meet again, which I believe is March 9th or around that date, that we'll have all of our background information for soil so that you guys can bring soil and we'll do soil texturing and talk about compost and all that great stuff. We'll be ready to do more hands-on stuff.
Are we not meeting on Friday?
Oh, Friday. I'm sorry. My Weezer class is on Saturday and Jim County's on Friday, and I'm still
Okay.
So
we'll see you Friday then.
People, we're Saturday the 24th is our next one, and then my Jim County is Friday on my
Okay.
9th. Sorry about
Yeah,
that.
okay. No. Okay. Great.
Woohoo.
So Montessa, this is Ann.
Yeah, Ann.
We missed a couple of classes due to unfortunate circumstances. Have you got a makeup plan for that, or?
So Ann, what I did is you guys had 2 classes with me, and I actually taught that material to my Jim County class while I was there last Friday. So now we're just kind of picking up all together. So we'll extend for 12 weeks like this. So you guys kind of had 2 bonus classes, and you can keep going with this group if that'll work out for you guys.
Okay, so every Tuesday and then Saturday classes that are once a month?
Yeah, February 24th is the next one.
Yep, that's what I have on my calendar too. So Ann and Jeff are from New Meadows, so they're coming down to my Weezer class. So they're on a different schedule than my Jim County.
Okay.
I actually had my father-in-law pass away 2 weeks ago, and he's the one that we own the dairy with. So that kind of disrupted the work schedule quite a bit, but we are back and going now. So.
Wow. Oh.
Yeah, and it's actually they met with the trust lawyer and it's all going to work, and we still get to be dairymen. So that
That's great. Good.
Okay. Any other questions?
I can't think of anything.
Well, thank you all for getting on here. We actually had a pretty good turnout, considering we've only got like 12 students to begin with, and I knew a couple people couldn't be on. So this same link will work every week. So this is kind of our room that we'll be doing this in, but I'll go ahead and send it out each week so you don't have to try to dig in your email.
Okay, great.
And then
And you'll
tomorrow
send us.
morning you'll get the recording for this.
Oh, great. Thank you. And the PowerPoints also?
And the PowerPoints also. I've got a note down here.
Is there any way that maybe the next time that we have the webinar, that you can send us the link to anything that we're...
Or the PowerPoints before so we can make notes on the PowerPoints?
Oh, that'd be great. That'd be great. I usually am editing them about a half hour before I'm here, so don't be too far ahead, but I will get those out to you.
Okay.
Okay.
Great.
All right. Thank you.
Okay, thanks. Hey, Mia, we can see you.
Hi. So we just got this figured out. We've been involved all the way along here. Hey, I did have a quick question.
Yes.
On the lasagna gardening, we start with the 2-foot process and then it goes down to 6 inches. Is that something that's covered for 6 months?
Actually, you want to leave it uncovered. If you cover it with like a plastic or a tarp, it'll go anaerobic on you and kind of get that gross sewagey smell. So you do leave it uncovered, but in our climate, you probably would want to water it still. You don't want it to completely dry out so it's not, breaking down. So you need to run the hose over it every now and then to keep the process going.
Okay. All right. And then, so that would be something that's more to be utilized in a raised bed then.
Yeah, or in a
Just
small
because
area. I've seen people put perennial beds on the side of their lawn this way, but yeah, it's not a whole field type process.
Okay. Yeah. Okay, great. Thank you, Montessa.
Very good. Okay, thank you, everyone. If you've got more questions, feel free to email along the way, and we'll see you next week on Tuesday.
Thank you.
Thank you.
Thanks.
Good night.
Good night.
Thank you.